I believe this is what you guys are supposed to go through, beginning our data-driven journey in Maji Ndogo. So I'm not going to read everything here because basically, okay, in Maji Ndogo we have this lady president called Aziza Naledi. So basically, what she's doing here is assigning a task of basically the thing that is supposed to be done here is to sort out the issue of water crisis in this particular setting, which is Maji Ndogo. So I believe Maji Ndogo is either maybe a city or maybe a continent or something. And the team lead here is this guy Chidi. So he's the person who is assigned to, you know, get all this done. Um, so what basically you need to do in this particular section, I believe you guys have gone through the content. Um, because if you haven't gone through the content, I think it will be a bit uh, hard for you to understand everything here. But I believe you've gone through the content at least. So what we need to do here is a data set has been provided. It's an SQL data set that you're supposed to download from Athena. And then based on what you've learned, I believe up to this point, you've learned things like data manipulation language and all that, data query language in SQL. So there are five, I think there are five. Yes, these are the five main things you're supposed to do. Get to know our data. So yeah, they say before we do anything else, let's take a good look at our data. We load up the database and pull up the first few records from each table. So you need to familiarize yourself with the data you've been provided with before querying and doing all that manipulation, right? So that is the first thing they're
Yeah.
mentioning here. Get to know your data and then dive into the water sources. So within the data, I think it's composed of various tables that have been properly named. So each table has particular sets of data that is, and I believe the tables are somewhat related. So dive into the water source. So we've got a whole table dedicated to the types of water source in our database. So let's dig deep into it and figure out all the unique types of water sources we're dealing with. So we have a table that's dedicated to water sources. We also have another one here for visits to water sources. And then we also have assess the quality of water sources. So the quality of water sources is a pretty big deal. We'll turn to the water quality table to find records where the subjective quality score is within a certain range and the visit count is above a certain threshold. So we also have a table that is dedicated to the quality of water. And then we also have investigate any pollution issues. We can't overlook the pollution status in our water sources. Let's find those water sources where the pollution test result came back as dirty or biologically contaminated. So we also have another table that is dedicated to pollution. So these are the five main things that you're supposed to do within this particular notebook, I mean, within this document. And then after that, whatever the outcome, it will be able to help you answer the questions that are on the MCQ. Okay, so without wasting time, I think let's open up my SQL workbench. I believe you have familiarized yourself with my SQL workbench. Um, if not, I believe there are contents on the Athena on how to download it. Basically, to download it, just go online, search for my SQL workbench. If you're on Windows, the process is straightforward. You basically download the installer and then you run the installer. It will run the scripts and all that. And then after that, you'll be able to have this kind of screen where we have the navigator on this side. So we have administration and schemas. So schemas basically are a schema is a database. A database is composed of tables. Okay, so those tables we refer to them as relations. So normally when you download or when you install Workbench, it comes with these three default schemas or databases. So these are system generated, so we are basically not interested in them. What we need to do here is to load our data sets, which is supposed to download from Athena, and it's an SQL data set. So I have downloaded it. I think it's yeah. So there's this file called additional downloads. Uh, you get it from Athena. You download it, you extract it because it's a compressed file. So when you extract it, you'll have all these. You have the D example notebook. This is a notebook file, and then we have data dictionary, which is a PDF. So I think this one describes the various tables that are within this particular database. Then we also have Jupyter source file. So this the example notebook, it's actually an SQL file, and then now this is a Jupyter notebook file. But what we really want is this MD water services, Maji Ndogo water services. It's also an SQL data set. So this is what we need to load into our Workbench, and then we start the querying process. So just come to files here and then open SQL script. So when you click on SQL script and then you click on the data set, it's basically an SQL script, and then click open. So this is it. This is basically a script that you can see it creates a database called MD Water Services. And then it also creates various tables. You can see create table with the column names here. Another table employee. So it will create all these tables. Another one is global water access, um, location, and all that. So after creating the tables, you can see they are also inserting data into the various tables. Like this one, you are inserting data into the locations table. Insert into location, and then you have the data set there. So basically, let's run this script to create the database, the tables, and also the data that we need. So to execute queries on SQL Workbench, basically you click this the lightning symbol. So when you click on that, I think there's an error somewhere. You have an error in that. Okay, good. Okay, it's loading a bit. Okay, perfect. Now I believe everything is created. So on the output section here, if there is an error, then this thing will be red, and then it will be an X. If everything runs well, you can see they are green and they have been ticked. So that means this script has run successfully. Now, since this is a schema that we just loaded here, we need to be able to see it here on the schemas here. It should pop up here. So let's refresh these, and then we have the MD water services schema here. So schema, and then when you click on the drop down arrow, and then you go to tables, you can see all the tables that are inside this particular schema. Or we can actually run a query here to see the tables. So first of all, we have to use the database. So it's MD water services. So if you run this query, it will, you can see it highlights this particular schema here. So it means this is the schema that we can now start running queries on. So that is that. And then if you want to see the tables that are within this schema, so you can just run show tables, and then when you execute, you can see it gives us all the tables that are within this particular schema called MD water services. So we have the data dictionary table, we have employee, global, water access, location, visits, water quality, water sources, and well pollution. All right. So we've loaded our data sets. Let's go back to this notebook and see what's required of us. So get to know our data set by start by retrieving the first few records from each table. How many tables are there in our database? What are the names of these tables? Once you've identified the tables, write a select statement to retrieve the first 5 records from each table. I don't think they showed you this at the academy, but when you access a new database in MySQL, a handy initial query to run is show tables. This will give you a list of all tables in the database. So we've just run this and we've seen a list of all the tables that are within this particular database. So basically they're saying if we run the show tables command, we should see something like this that has all the tables. So these are 1, 2, 3, 4, 5, 6, 7, 8 tables. So I believe that's what we have here. We have 1, 2, 2, 3, 4, 5, 6, 7, 8. So we have all the 8 tables. So that means our query is okay. And then they've also said that once we've identified the tables, write a select statement to retrieve the first 5 records from each table, right? So basically, what normally happens is if you're given a data set, like in this case, we've been given these data sets, you need to familiarize yourself with the data sets, okay? You need to understand or know the names of the tables. Like in this case, we have all these tables within this particular data set. Familiarize yourself with the kind of data that each and every table has. So that is basically why they're telling us to run a select query to see the first 5 records of each and every table, right? So I believe you know the select query. So basically, we want to see the first 5 records of each and every table within this particular data set, just to familiarize ourselves with the kind of data set that we have at hand here. So you can select all from, let's start with the first table here, which is data dictionary. So they've said we select the first 5 records. So what this query that I've written here does is select, will basically select, and then when you put a star here, it means select all columns from this particular table, all right? But they want us to limit it to 5 records, meaning 5 rows. So we want to see the first 5 rows only. So it means here we'll say limit, and then we put 5. Okay, so limit 5 meaning it will give us the first 5 rows only. So if we run this, you can see this is the result that we get from the data dictionary table. So data dictionary table here has it has the table name column, and then column name, description, data type related to. So from this query that we've run on the data dictionary table, you can see the kind of data this table has and basically what it does. So first, the data dictionary table, from whatever we have from the output here, you can see that basically it describes the tables within this database. Okay, so it has the table name. For example, the first one is employee table. So employee table, and then the column name, we have a column like assigned employee ID, and then the description of this particular column. So this is a unique ID assigned to each and every employee. And then the data type of this assigned employee ID column is integer, meaning it stores numbers. And then it's related to visits. Visits is also another table within this particular database. Okay. So the first 5 here are actually all employees table. Maybe we can put this to 20 and see if there are other tables. So if we run, you can see after employees table, we have visits table. So visits table, and then it has all the columns. The columns here are record ID, location ID, source, and their descriptions and the data types, and whichever table, other tables within this particular database that they are related to, right? So this is what we get when we run the first 5 rows on the data dictionary table. Let's go to the next table, which is employee. We can just replace it here. So employee has these columns: assigned employee ID, and then the employee name, phone number, email, uh, and then the address, and then province name, town name, and position. So if you take an example of the first employee has an employee ID of 0, or her name is Amara Jengo, and then the phone number is there. The email, this employee does not have an email. You can see it indicates null. And then the address, this is like the physical address, street or something is 36 Pwani Changani Road. And then this person comes from Sokoto province, from a town called Ilanga, and his position is a field supervisor, right? So the employees table from the output we have here is basically describes the employees within this particular section, right? The next table here is global water access. Global water access. So global water access has data on, I think from the name, you can already tell global water access. So it has, and this is also another data set that I believe you guys have already familiarized yourself with when you are doing um, spreadsheets or Excel. So it has columns like name, which is the name of a country. Region is where the country is, like it's like region within a continent. And then we have year, population N, population U, and all these. So I believe this one has the highest number of columns, right? The next table here is location. So we can also check on location. So location, we have location ID, address, province, province name, town name, and location type. So I believe these are different locations where we have the water sources. So we have a location ID. For example, we have these alphanumerical type of data, and then the address is also there, and then the name of the province, the town, and the location type. So location type is either urban, which is in an urban area, or rural, which is in a rural area. And then we also have visits. Visits, we have record ID, we have location ID, source ID, time of record, visit count, time in queue, and assigned employee ID. So these are like people who are visiting the various water sources, and then they are recording their findings. So we have the record that starts from 0, and then the ID of the location the person visited, the source of water that is in that particular location, and then the time, uh, the number of visits, which is the visit count, and then the time in queue, how long people takes to queue for water in that particular water source or location in that case, and then the assigned employee ID. This is the ID of the employee who visited this particular water source or location. And then we also have water quality. So water quality, basically it records, we have the record ID, subjective quality score, and then the visit count. So this basically records the quality of water. Okay, we have this column, subjective quality score, which basically is a score on the quality of water. So I don't know the metrics they're using to measure this, but you can see some at 0, 1, 5, 10, and all that. And then the visits count basically is the number of visits to that particular water source. Next one, we have water source, and then we also have well pollution. So we have water source. Water source is basically the water source. Okay, so we have source ID, we have type of water source, and then number of people served. So type of water source is basically the type of that particular source of water. So like this is a tap in a home. Okay, tap in home. And then number of people served is the number of people that particular tap serves. We also have tap in home broken. We have well and all that. We have very many. I think we also have rivers and all that. And then finally we have well pollution. Pollution. So well pollution records. We can see source ID, date, description. Description is the type of pollutant. And then we have pollutant, ppm, and then we have biological, and then we have results here. So this table basically describes whether a water source is polluted or not, and if it's polluted, what are the pollutants or the contaminants of that particular water source, right? Okay, so let's continue. So we've done this. Then it looks like someone took time to name all these tables pretty well, because we can kind of figure out what each table is about without really having to think too hard. Yeah. So I think this is a convention when you're creating tables. Uh, you should provide descriptive. The names of the tables should be as descriptive as possible. Let's have a look at one of these tables. Let's use location, so we can use that killer query select all, but remember to limit it and tell it which table we are looking at. So we've actually done this. We've had a rough look at basically all the tables within our database, and we've at least tried to familiarize ourselves with the kind of data that is in each and every table, right? This is the visits table again, just the same thing that we have done. This is the water source table, the same thing that we have done. And then look at this particular section. They're saying a data dictionary has been embedded into the database. If you query the data dictionary table, an explanation of each column is given there. So data dictionary basically is a description of the tables within our database here, right? So that's the first section that we have done, basically getting to familiarize ourselves and know our data. We have done that. Now, we want to dive into the water sources. Now that you're familiar with the structure of the tables, let's dive deeper. We need to understand the types of water sources we are dealing with. Can you figure out which table contains this information? So we need to find the table that contains water sources, right? And then once you've identified the right table, write an SQL query to find all the unique types of water sources, right? To find all the unique types of water sources.
There was a question from Amal that how can I expand my table view like yours?
Expand the table view. We have these, for example, you see there's it's divided into sections. So basically, if you hover over that section, there's that cross that will appear. So when you hold on that, you can basically expand it however you want. Same to these other ones down here. When you hover and then that cross comes, you can always expand it the way you want. Okay.
Okay.
Okay, correct. So now that we are familiar with the structure of the tables and the kind of data that our tables have, we need to understand the types of data sources that we are dealing with in this case. So here we need to identify the table that uh, has information on the water sources, and then we need to query that table and find the unique types of water sources that we have in Maji Ndogo, right? So to do that, I think first of all, we can run the show tables query. I think it's up here. So let's run it to get the tables. And then from these names, we can already tell which table contains information on the water sources. We have a table called water sources here. So basically, we're going to do that. We're going to use that. So what we need to do is they have asked us to list the unique types of water sources that we have in Maji Ndogo. But before that, we need to know which column contains the types of water sources. So to do that, we can either select the first few rows of the water source table to get familiar or know the names of the columns, or we can use the describe statement. So you can write describe and then the table name. It's water source, yes, water source. And then if we run that, it will give us descriptions of the various columns that we have in this particular table. So for example, we have field here, and then we have source ID. So that's a column within this table. We also have type of water source, which is also another column. And then we have a number of people served. Okay. It also gives us the type of data that is stored on each and every column. So number of people served is an integer, meaning it's numbers. Null, yes, it means can always be null sometimes. And then we have the type of water source, which is a variable character, meaning it's a combination of letters, numbers, and whichever type of data that you want to put there, as long as they are in strings or in quotations. And then we also have source ID, which is also a variable character, right? So you can use this, or you can just select the first few rows by saying select all from water source, and then we limit it to 5. So if you run these also, um, we get the source ID, type of water source, and then the number of people served. So again, from here also you can get the names of the columns. So these people want us to get the unique types of water sources that we have in this case. Now here we have tap in home broken, well, and all that. We don't know all the types of water sources, but if we run this without the limits, it will give us everything. So if you scroll down, you can see all the types of water sources. But you see, for example, tap in home is here, 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 and here. Well also is repeated. So this one does not give us the unique types of water sources. We want that if it is well, it's just well. It doesn't have to give us the repetition or instances where well has been mentioned, right? So that is what we want because we want the unique ones, okay? So we need to know all the types of water sources, unique types of water sources that we are dealing with in this case. Now to do that, let's comment this one out. And we write a query. Now our query will be select Then because we want unique, we're going to use distinct. Distinct. I hope that's the spelling of distinct. Distinct. And then we want distinct or unique water sources. So we want this. We want it to select from the uh, type of. This is water with small water source. So select distinct type of water source from the table water source like this. So when we run this, it's going to list distinct water sources that we have in Maji Ndogo. So you can see we have tap in home, we have tap in home broken, we have well, shared tap, and river. These are the main types of water sources, the only types of water sources that we have or we are dealing with in this case, right? River, of course, you know, the people get water from a river. Shared tap is like a community tap where everybody can always come together and collect water. Same to a well. And then tap in home broken is basically people have taps in their homes, but those taps are not functional. They're broken. And then we also have tap in home. These are now taps in homes, but they are functional, right? Um, let's continue. So let me quickly bring you up to speed on this. Okay, you can see that's the same thing these people have also gotten here. Tap in home, broken, well, shut up, and a river. So, and then they're describing every type of water source that you have in this case. So river, people collect drinking water along a river. This is an open water source that millions of people using in Maji Ndogo, right? And then you can see a small picture there of people basically collecting water from a river. We also have a well. These are sources. These sources draw water from underground sources and are commonly shared by community, right? Since these are closed water sources, contamination is much less likely compared to a river. So wells are closed, so it's not easy to find contaminants. Unlike rivers, which are just open, anything can always fall into a river. People can throw dead animals into a river, and that is contamination. So that is a well. And then we also have shared taps. This is a tap in a public area shared by community. Okay. So tap, basically, it can either be getting water from underground or maybe it can be collecting water from a river or maybe some sort of a system that is interconnected. Water flows through pipes and all that. So that is a shared tap. And then we also have tap in home. These are taps that are inside the homes of citizens. On average, about 6 people live together in Maji Ndogo. So each of these taps serve about 6 people. And then you can see an example of somebody's uncle's tap in yeah, tap in somebody's uncle's home, right? So that is a tap in home. And then we also have broken taps in home. These are taps that have been installed in a citizen's home, but the infrastructure connected to that tap is not functional. So like I mentioned, these are taps that are in the homes of people, um, but they are broken. They are not functional. They are not working, right? Um, so an important note on the home taps, about 6 to 10 million people have running water installed in their homes in Maji Ndogo, including broken taps. If we were to document these, we would have a row of data for each home so that one record is one tap. That means our database will contain about 1 million rows of data, which may slow our systems down. For now, the surveyors combine the data of many households together into a single record. So that is why if you query the water sources data and then you look at the number of people served, you'd expect that maybe in a home, you'd expect that a tap serves like one person. But you see, there's a part up there that they mentioned that on average in Maji Ndogo, you might find like a homestead has an average of 6 people. So all these 6 people are using a tap. So instead of listing one tap, one person, it does not make sense. It's not logical because we are going to end up with a very huge database that has, we can say, probably like a repetition, right? So instead of that, you have to combine these things. So here, for example, the first record, which is I believe is a society, is for tapping home that serves 956 people. What this means is that the record of about 160 homes nearby were combined into one record with an average of 6 people living in each house. And then there's that mathematics behind it that has been listed, mentioned there, which is 160 times 6, which gives you the 956 people. So basically, one tap in home or tap in home broken record actually refers to multiple households with the sum of people living in these homes equal to number of people served. So that is the second part. Basically, you just need to know um, mm, the distinct or the unique water sources that we have in Maji Ndogo, or at least you need to understand and know where do people from Maji Ndogo get their water from. Okay, and you can see we have the 5 main ones, which are river, wells, tapping home broken, and I don't know which was the last one. Okay, so let's continue to the third part, which is unpack the visit water source. Um, so we have a table in our database that logs the visits made to different water sources. So you need to be able to identify that table, basically a table that records the visit to various water sources. And then they're saying write an SQL query that retrieves all records from this table, that retrieves all records from this table. They are referring to the table that records number of visits to each and every water source. So we need to retrieve all records from the table, from that particular table, where time in queue is more than some crazy time like 500 minutes. How would it feel to queue 8 hours for water? 500 minutes divided by that is around 8 hours. Okay, so let's do that. Let's run show tables again to identify which table records the number of visits per water source. So we have this one here, which is the visits table, right? So this is the table we are going to use. Okay. Um, so what was that thing they wanted us to do? Write an SQL query that retrieves all records from this table, where the time in queue is more than some crazy time, say 500 minutes. So you need to write a query that will retrieve all the records from the visits table, where the time in queue, I believe, so time in queue is actually a column in the visits table. Okay, so where time in queue is more than uh, 500 minutes. Okay, so let's first of all write select all, oops, all from visits, and then let's limit it to maybe 10 and just have a rough look at what this table has. So we have record ID, which is the ID of the record, and then we have location ID. This is where this particular water source is located. I'm referring to the first row. So we have location ID, we have source ID, which is the ID of the water source. Time of record is the time this record was taken, which records year, month, date, time in hours, minutes, and seconds. Visit count is how many times that particular water source was visited, and then time in queue. This is the column we're interested in. So this is how long it takes for people to queue for water in that particular water source. So if it's 15, it means if you go fetch water from that particular water source, in this case, this first water source, you are probably going to take 15 minutes for you to actually collect water and get out of that place, right? So that's the timing queue. And then assign the employee ID. This is the ID of the employee who went and took this particular record, right? So what they want us to do is to write a query that will give us records of that will give us all the records from the visits table where time in queue is more than 500 minutes. Okay, so let's write that. So we need to just select all because they want all records. Okay, so we are going to select all rows from the visits table. Now here, we're not just going to use the select query alone. We're also going to uh, add a where clause. So we are going to select all the columns from the visits table, and then we use this clause, the where clause. Okay, where this is timing queue. Timing queue. What's the spelling of queue? Where timing queue. They said where timing queue is more than 500, so we are going to put greater than 500. Okay. So basically, what this means is we want you to select, like telling the uh, this thing that we want you to select all the columns from the visits table, and then when it comes to this time in queue column, we want you to just pick records where the time in queue is more than 500. Okay, the time is recorded in minutes, right? So let's run that, and then you can see what we get here. So you can see all the records that have been retrieved here. If you check a time in queue, it has to be greater than 500. Okay, this is 515, this is 512, and all that. So these are sources of water where when you go to fetch water from these sources, you are highly likely to take more than 500 minutes to collect water from that particular source. Okay, like in this case, the one that has been highlighted, you're going to take 523 minutes to pick water, to collect water from that source. This one is 511. So every record here is more than 500. All right. So that is that. So this is the table that is, so it gets this table. The first one was 515, and then 512, 529. Let's confirm. Yeah, 515, 512, 529. So we got the correct thing. So how is this possible? Can you imagine queuing 8 hours for water? Right, but that is what some people go through here in Maji Ndogo. So I'm wondering what type of water source takes this long to queue for. We'll have to find that information in another table that lists the type of water sources. If I remember correctly, the table has type of water source. The table has type of water source and source ID column. So let's write down a couple of these source ID values from our results and search for them in the other table. So he has recorded a couple of source IDs that is going to query from another table. So let's read along and see what they basically wants to do. So if we just select the first couple of records of the visits table without a where filter, you can see that some of these rows also have 0 minutes queue time. So let's write down one or two of these two. If you just select the first couple of records from the visits table. So from the visits table, let's run that and see. From the visits table, select all from visits said, without adding or limiting. So if you run that on the visits table without the where clause, you can see we have some sources that have 0, right? Time in queue is 0. So you can see that we also have a couple of others down here. So there are some where uh, uh, time in queue is actually 0, right? So I chose these two. So it's basically trying to pick um he's picking a source ID for a couple of columns that have a time in queue as 0. So for example, these and others. So he has picked these two also. Okay, so now back to the water source table. Let's check the records for those source IDs. You can probably remember these are cool and a not so cool way to do it. This is what I get. So this is what he gets. So these are the source IDs that he has picked from the visits table that is trying to query. So let's do the same. Let's basically just use these source IDs here. And now we are running this query on the water source table and see what we get. It should be the same as whatever he's having here. Um, so he's running it on. Okay, let's see what he got here. So he has the source ID, type of water source, and number of people served. All this is from the water source table. Let's describe water source and see what it has. So water source ID, type, and all that. Okay, so that's good. Okay, so let's write a query that will give us this kind of table that will give us this. So basically it means we're going to ensure that on the source ID column, we actually have these exact IDs. All right, we're going to have those exact IDs. So let's select, we can select source ID. Actually, let's just select all. So we select all, or what do we do? Do we select the source ID? No, let's just select all, and then from water source. So select all from water source, but then we want to incorporate the source IDs that we've just seen there. So we are going to use our where clause. So we're going to say where source ID, it's source ID. So here we want to incorporate very many source IDs. Like here there are 1, 2, 3, 4, 5, 6, 7, 8. So you want to incorporate 8 of them. Maybe you can put around like 4 because all these are so many. So we want where source ID, and then we want it to be in. So source ID in, and then we are going to list the source IDs. So we are going to have the first one there, and then we are going to copy the second one. Just there. The third one. Maybe let's pick this for, yes, like that. So when we run these, we should have the same thing that they have there. So we have the first one is shared tap, and then the number of people it serves. You can see 3398, and then the second one is well, which serves 210. Another one is tap in home, and then this one is a shared tap. So that's the same thing that they have here. Let's see. Uh, Dirty well. Wow, do we have that? Why do they have it as biodiary? I think I did not clean my data. Okay, but this one is 210, 496, 33, 22, 496, 33, 22. Okay, good. So I added a couple of others. Sorry. Well, if you check them, you will see which sources have people queuing. The field surveyors also let us know that they measured sources that had queues a few times to see if the queue times change. Um, the field surveyor also let us know that they measured sources that had queues a few times to see if the queue times changed. Hmm. Okay, nothing else after that. Okay, all right. Since there's nothing else after that, so I don't know why we had to do this, but okay. Uh, Part number 4 is that assess the quality of water sources. So that's the part number 3, basically trying to understand the visits table, which basically records the has data that was recorded by people who visited various water sources. All right, trying to understand how long it takes for people to queue for a water source and all that. So you're onto the fourth part, which is to assess and understand the quality of the various water sources that we have in Maji Ndogo. So the quality of our water sources is the whole point of this survey. We have a table that contains a quality score for each visit made about a water source that was assigned by a field surveyor. They are assigned a score to each source from 1 being terrible to 10 for a good, clean water source in our home. So if it's 1, it means it's not so good of a quality, but 10 is a clean water source, right? Share taps are not rated as high, and the score also depends on how long the queue times are. Look through the table record to find the table. So you need to find the table that records the quality of water sources. Okay, let's continue. Let's check if this is true. The surveyors only made multiple visits to shared taps and did not revisit other types of water sources. So there should be no record of second visit to locations where there are good water sources like taps in homes. So basically, taps in homes do not experience a lot of issues, and that is why basically their visit counts is just basically recorded as 1 because it basically means these employees, when they visited, or the surveyors in this case, when they visited these taps in homes, they did not record a lot of problems. Queue times are mostly 0, so they don't possess a lot of issues, and that's why there's no need of going for a second visit and all that. Okay, let's continue. So please write a query to find records where the subject quality score is 10. A query to find records where the subject quality score is 10. And then we have a comment here, only looking for home taps and where the source was visited a second time. What will this tell us? So we need to write a query. Basically, we need to first of all identify the table that records the quality of water, right? And then we need to write a query, which will give us records where the quality score is 10, right? And then they're also saying here, only look for only, okay, they're basically trying to target uh, taps in homes. So basically where the source was visited a second time, okay? So you want to write a query that is going to query the table that contains quality of water source, where the subject quality score is 10 and the source was visited a second time. So it means the visit count is 2, right? I get 218 rows of data, but this should not be happening. So let's first of all write the query before we continue the explanations. So you first of all need to identify the table that records water source quality. Um, okay, let's see from this side instead of, okay, we have the water quality here. So that's basically the table that records the water quality. Maybe we can run select all from water quality. Just to see what it records. So, okay, let's limit it to 5. So this table records, we have the record ID, we have the, is it subjective or subject quality score? Yeah, it's subjective quality score, and then the visit count. So let's go back. So we have that table. So write a query to find records where this is supposed to be subjective, where subjective quality score is 10, and where the source was visited a second time. So we need to retrieve all rows where the subjective quality score is equals to 10 and the visit count, visit count is equals to 2, right? So let's write that. So we need to select all from the water quality table, from water quality. So we select all from water quality where this is subjective quality score. So subjective quality score is 10. So it's equal to 10. It's strictly 10. And then uh, and visit count. Visit count they've said is 2, right? And visit count equals to 2. So when we run this, we should get this. So we have whatever they want here. So subjective quality score is 10. And then you can see visit count is 2. So this gives us all the records where subjective quality score is 10 and the visit count is recorded as 2. So let's get more information. So I get 218 rows of data. Let's confirm if our rows are actually 218. Maybe so we can put here counts and then we run these. Yeah, we get 218. So it means we have the right thing. So let's continue. But this should not be happening. I think some of our employees may have made mistakes. To be honest, I'll be surprised if there are no errors in our data at this scale. I'm going to send President Lady a message that we have to recheck some of these sources. We can appoint an auditor to check some of the data independently and make sure we have the right information. Okay, so as much as we've gotten 218 rows, it means there are some errors that have happened with this table called water quality, right? Probably some records are not have not been done well. So that is why we need to actually investigate the pollution, right? So that is what brings us to the fifth thing that we're supposed to do here, which is to investigate pollution issues. Okay, so did you notice that we recorded contaminations of pollution data for all of the well sources? Find the right table and print the first few rows. So you need to find the table that records the pollution issues, and then you print the first 5 rows. Okay. Pollution. So you can check this is water quality, water source. So we have well pollution. Yeah, I believe that records the pollution. Then we print the first 5 rows from well pollution. Then limit 5. So we run that, then this is what we get. Okay, this is interesting. So we have source ID, which is basically the water source ID. We have the dates and then description. So description, we have something like bacteria and then the type of bacteria. And then we have pollutant, ppm, we have biological, and then the result. So let's continue reading from our document here to understand what these things basically record. So that's the same thing it gets here. So let's continue. So it looks like our scientists diligently recorded the water quality of all the wells. Some are contaminated with biological contaminants, while others are polluted with an excess of heavy metals and other pollutants. Based on the results, each well was classified as clean, contaminated. So contaminated can be biological or contaminated chemical. All right. It's important to know this because wells that are polluted with bio or other contaminants are not safe to drink. So basically, what this thing does is it's telling us is that we have the results column here. So results tells us what kind of the kind of water that each and every source has. So if it is clean, like for example, we have clean here, it means this water source, this water here is safe for consumption because it's clean. It does not contain any contaminants. But if it's written contaminated, it means it contains contaminants. And then chemical is the type of contaminant that is in that particular water. So in this case, this water is contaminated by chemicals. If it's biological contaminant, then it's indicated as biological. Okay. So it's important to know this because wells that are polluted with that are not safe to drink. It looks like they recorded the source ID of each test, so we can link it to a source at some place in Maji Ndogo. Okay, that's good. In the well pollution table, the descriptions are notes taken by our scientists as text, so it will be challenging to process it. The biological column is in units of CFU per ml, so it measures how much contamination is in water. Okay, so we have the biological column there that measures how much contamination water has. Okay, so 0 is clean, meaning if this biological column is recorded as 0, it means that water is clean. And anything more than 0.01 is contaminated. So if on your biological column here, there's a record that is 0.01 and more, it means that water source is polluted or contaminated. It's not safe for consumption. Okay. Let's check the integrity of the data. The worst case is if we have contamination, but we think we don't. Okay, so people can get sick. So we need to make sure there are no errors here. So the exercise they want us to do here is write a query that checks if the results is clean, but the biological column is is greater than 0.01. This is the greater than sign. Okay, so we need to write a query that will give us records from the well pollution table where the result column is clean. Okay, so everything is recorded as clean, but the biological is greater than 0.01. This means that as much as the water source, for example, let's take this first row here. This first row, you can see it has been recorded as clean on the result column. And remember, we've already said that clean means that water is safe for consumption. But somewhere up here, they have explained for us something here. This line here. They have said that this part here. They have said that the biological column is in units called I don't know whatever that unit is. It measures how much contamination is in the water, and zero should be clean, and anything more than 0.01 is contaminated. So you see, this particular water source here, as much as the result indicates that it's clean, it actually contains contaminants because the biological is greater than 0.01. So this is where the error is. Okay, this is where we have the problem. All right, and we're going to try and fix it. But for now, they have told us to write a query to check if the results is clean, but the biological column is greater than 0.01. So you need to know these records where the result was recorded as clean, but the biological is recorded as greater than uh, 0. Uh, 0.01, right? So let's write that query. So we need to select. So we're basically selecting everything from well pollution. Select all from well pollution, and then where. So they've said where the results is recorded as clean. So results equals to, we have to put it in quotes because clean is a variable character, is a varchar. Where result is clean, so result has been recorded as clean. And what was the next column? Biological, yes. And biological is greater than 0.01, right? So let's see. And voila, we have it here. You can see. So it's actually a lot of data. And this is actually wrong information, right? This is wrong information because somebody might see, this is clean, when in real sense, it actually contains contaminants. You can see biological is actually 35.0068. So it contains a lot of contamination, right? While you are there thinking it's clean, right? So let's continue. We've written that, and yeah, this is what we got. So if you compare the results of this query to the entire table, it seems like we have some inconsistencies in how the well statuses are recorded. Specifically, it seems that some data input personnel might have mistaken the description field for determining the cleanliness of the water. Okay, it seems like in some cases, if the description field begins with the word clean, the results have been classified as clean in the results column, even though the biological column is greater than 0.01. So this kind of things by the way normally happens when you are doing data collection. Somebody might not be professional enough because, okay, for people who are collecting the data, they are field surveyors, probably they are not scientists who are able to tell that, who understands whatever is going on here. So what that person is saying is these people, they were checking at the description column, and whenever they encounter the word clean, they just assume that this water is clean and safe for consumption. So the results is just recorded as clean, even though the biological is greater than 0.01, meaning the biology it contains contaminants, right? Um, even though the biological is greater than 0.01. So when you work with the real world data, we may find inconsistencies due to data being misinterpreted based on a description rather than its actual values. Let's dive deeper into the cause of the issue with the biological contamination data. Vuisile, all these are names. So Vuisile has told me that the descriptions should only have the word clean if there is no biological contamination and no chemical pollutants. All right. So it means the description should contain clean if there are no contaminations at all. Some data personnel must have copied the data from a scientist's notes into our database incorrectly. So we need to find and remove the clean part from all the descriptions that do not have biological contamination. So this mistake is not made again. So we need to correct that. That's the first thing. The second issue has arisen from this error, but it is much more problematic. Some of the field surveyors have marked wells as clean in the results column because the description has the word clean in it. Okay, even though they have a biological contamination. Okay, so we need to find all results that have a value greater than 0.01 in biological column and have been set to clean in the results column. So that's the second thing we need to do. Okay, so first, let's look at the descriptions. We need to identify the records that mistakenly have the word clean in the description. However, it is important to remember that not all of our field surveyors use the description to set the results. Some check the actual data. Okay, so hints. So they have given us a hint here. To find these descriptions, search for the word clean with additional characters after it, as this is what separates incorrect descriptions from the records that should have clean. The query should return 38 strong descriptions. Okay, so we need to write a query for that. So basically what we need to do is we need to select from the well population, and we need to select where the results was recorded as clean and the biological is greater than 0.01, and the description column um, starts with the word clean. So it should be clean and then some other characters. If it is just clean alone without the other characters following, then we are not going to select that. Okay. All right. So that's an interesting one. So basically, what you need to do here is, for example, let's look at this. Look at this row here. So you see, this row was recorded wrongly because it has clean and then bacteria and then the name of the bacteria. And then if you check at the biological, it's also greater than 0.01, and also result has been recorded as clean. So it means this water source here, it has contaminants because the biological is greater than 0.01. And then the type of contaminant is a bacteria, and then we have the name of the bacteria. But whoever was recording this, they put this as clean because in the description, they saw that they have that word clean. So when they saw clean, on the description, they assume that this source is good for consumption. So in the results, they just recorded it as clean. So you want to select all of these and then isolate them and go to the next instruction on what you're supposed to do next. So we need to select, and we are selecting all from well pollution, of course. So we are selecting from well pollution, where let's try to be a bit professional. So where we are going to start with the I think let's start with the results. Where results is recorded as clean, right? So result is recorded as clean, uh, and result is recorded as clean. Biological is greater than 0.01. Biological is greater than 0.01. And description. Now we only want uh, uh, rows where description starts with the word clean and it has some other some other things. So basically it means description should start with the clean, and then it needs to have some other things here. All right, if it's just clean like this, then this was recorded correctly. Okay, so here we're going to say end description. So we want our description like. Now here we're going to use what are they called? Um, wildcards. Yeah, they're called wildcards. So that is the percent. I think we also have underscore like this. So what percent does is, if you have a word, for example, when we write clean, what this means is we have the word clean, and the percent means clean and some other things that we do not know, right? If we put something like this, if you say underscore a, it means we want this particular sentence to start with a, and then after a, we are going to have some other characters, right? So these are the wildcards, the underscore, the percent. I think there's some others that I've probably forgotten. So you have description like uh, clean. So you have to put that percent sign, right? So let's try and these correct. Now if we run these, you can see we are getting everything that we want, right? So you see all these columns in the description column, you can basically see everything starts with clean, and then we have some other thing after clean, right? So basically all this was recorded wrong. Look at the biological. They are very, very much greater than 0.01. Yet on the results, it has been recorded as clean, right? Okay, let's continue. So the query should return 38 wrong descriptions. Let's confirm if they're 38. Let's count. If we count these, correct, they're 38. So that gives us the correct output. Now, we need to fix these descriptions so that we don't encounter this issue again in the future. So we need to fix that issue. Looking at the results, we can see two different descriptions that we need to fix. Two main descriptions that we need to fix. All records that mistakenly have clean and then bacteria and then the name of the bacteria. For example, the first one is E. coli should be updated to bacteria E. coli, meaning we need to remove the clean. We need to remove that part clean. Okay, we need to remove that part so that it just remains the type of contaminant here. So it means it's contaminated by bacteria, and then also the name of the bacteria that has contaminated that word. Another one is all record that mistakenly have clean and then bacteria this. I don't know how to read this. should be updated to bacteria, and then that's the name of the bacteria. Okay, so that's the first thing we need to fix. The second issue we need to fix in our results column is our results column. We need to update the results column from clean to contaminated, and then biological, where biological column has a value greater than 0.01, right? So it means basically, see, whatever we have here, we need to correct this. So it means, for example, if you are on the first row, we're going to remove this first part that is clean so that it remains bacteria and then the name of the bacteria. And then because the biological is greater than 0.01, instead of clean, because this is not clean water, we need to update it with contaminated. So here it's supposed to be written contaminated and then biological, because it's a biological contaminant, because biological is greater than 0.01. Okay. So that's the second issue we need to fix. Okay, so here is how I did it. So this is, I believe you guys know what pseudocode is. So this is like some sample pseudocode that we have been given that you're supposed to use to fix this. So we have case one, update the descriptions that mistakenly mention clean bacteria, blah, 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 to bacteria equally. So you remove that section written clean. And then case one part B is to update descriptions that mistakenly mention clean bacteria, and then that again you remove this section of this of the description that is written clean. And then the second one is update the results to contaminated biological, where biological is greater than greater than greater than greater than 1. Okay, so we need to update our table. I think down here they told us before we update the table, we need to create a copy. Yeah, so we need to create a copy of this well pollution table. We will get a copy of well pollution called well pollution copy. Now we can make changes, and if we discover there's a mistake in our code, we can just delete this table and run it again. So instead of, because we want to update this table, we want to update the well pollution table. So instead of running the update directly on this table, we're going to make a copy of the well pollution table, and then that copy is what we are going to update. Okay, that copy is what we want to update. So actually they have given a command here. A command has been given to create a copy. So create table. This is the command you use to create a table. So of course we want to create a copy of the well pollution table. So this table that we are creating, we want it to stay in this particular in this database, which is our database, MD Water Services. So you say MD Water Services dot well pollution copy. So this is the name of the new table that we want to copy contents of the well pollution to. All right. So we want to we are creating a table, and then we are basically copying. So when you say as, and then you select everything from well pollution. So it means everything from well pollution will be moved to this table called well pollution copy, right? So let's make a copy here first, and then before we do some updates on that table. So that comments out, and then let's run these. So if we run these, let's refresh these and see if a copy was made. Yes, good. So you can see there's well pollution copy here. So the copy for that particular table has been made. So that is perfect. So that is perfect. So That is that. So let's go back. Before we make these changes, here is another nugget of advice. Begin complex queries by commenting on what you will do. This helps us to think through problem before we write code to solve it and to answer. That's just some silly advice, which is actually very good. Then add how we will do it. So this is how you are supposed to update um, that particular um, that particular table. So we want to follow these things up here to update our table, right? The first thing we need to do is update the descriptions that mentions clean bacteria E. coli to bacteria E. coli. And then the one that mentions clean bacteria and then this thing here that I don't know how to read, we also update it to this. Okay, that's the first thing that you want to do, right? Then after doing that, we are going to go to the second part. Update the results to um, contaminated biological, where biological is greater than 1, then the result is written as clean. So let's start with the first case. Okay. So this first case, we're actually here we're going to write this query, and then we're going to copy paste here, but then we are going to change the name of the bacteria alone. Still work on the well position copy first. If everything runs well, you can transfer it to the main table, right? So of course we want to update. So update, we are updating well position copy. Okay. So we are update well position copy and then sets. So set, this is how you update. So you first of all start with the update command and then the table you want to update. And then set basically is going to tell us which columns you want to update. Okay. So set, we want to update the, what was the column name? Okay. Let me just run this real quick and well position. Let's limit it to 5. And to see the column names. Okay, good. Oh, perfect. So set. So we want to set the description. So we want to set the description. What was that thing? So you want to set it to bacteria E. coli. Okay. So let's start with this. So set description to bacteria E. coli. Let's remove this. Set description to bacteria E. coli where description is uh, equals to this thing that starts with clean. I think it's like that. Starts with clean and then bacteria equal, right? So this is what we're supposed to do. Maybe I need to separate it a little bit. So update the well pollution copy, but then you want to set the description column to this, where the description was initially this, right? So let's run this. We have an error. Update pollution. You're using safe. update mode and you try to update a table without aware that uses key column. To disable safe mode, so we need to disable this safe mode, and then our query should just run fine. So let's disable the safe mode. I think we can just do it up here. I think I should have done this before we started this. It's always SQL safe updates. Is it updates or updates? Safe updates equals 0. Okay, now let's try and run this. Now it should update. Okay, good. Now it's updated. Now it's updated. So we need to run this and then remember the same command. We need to apply it to this second one. So this is starts here like this. So this is going to be here and also here. Yes, we need to run this one also, and it has run very well. You can see there is no error here. So after that, now we are done with case one. That is both case one A and B. So we go to case two. Update the result to contaminated biological. So contaminated biological, where biological is greater than 0.01 and the current result is clean. Okay, so we need to also create a query for that. So we comment that one out, and then we again run an update. So again we update well pollution copy, update well pollution copy, and then set. So this time round we need to set our results. So results, we set results to, what did they say? Results to contaminated biological. So contaminated biological, where biological is greater than that and result is clean. So this one, results, we update it to contaminated biological, right? Where contaminated biological, where biological is greater than 0.01. And results is clean, right? Results is clean. So again, we update that. So it has run so well. So let's continue. Actually, there's the command here that you just need to fill. Okay, you need to complete it. So this was the how you update. So update the well pollution table, and then you set description to this, where description was initially this, and then you do the same for the other bacteria. So you need to fill in the rest. Now, when we change any data on the database, we need to be sure there are no errors, as this could fill the database with incorrect values. A safer way to update is by testing the changes on a copy of the table first. So we already did that. We'll get the copy of well pollution, call well pollution copy. Now we can make changes. We've already done that. Okay, here's the command that we have just written. Um, we can check if our errors are fixed using the select query on the well pollution table copy. So let's run this. So if we run this and if our query runs successfully, we should not get any errors. So let's comment this out, then paste that. Very good. Now, we haven't gotten any errors. And if you look at the section that is supposed to display the output, it's blank. Why is it blank? Because you see here, we selected uh, where description like. You remember this command, description like clean, and then followed by some other characters. You see now there's nothing like clean and other characters. And then also result is clean and biological greater than 0.01. We've also corrected that. Now result is not clean and biological greater than 0.0. Where biological is greater than 0.01, result is now written as contaminated biological, right? I think another way we can test is let's just select all from well pollution copy. So if we run this again, now you see where where biological is greater than 0.01 is now actually written as the result is contaminated biological, right? And then this is clean because the result is not biological is not greater than 0.01. Okay, so that's why it's clean. Biological is 0, that's why contamination is chemical. But where biological is greater than 0.01, you can see actually see that contamination is biological, right? So it means we got it right. And then if we sure it works as intended, we can change the table back to well pollution and delete the well pollution table. So if everything works well, like in our case, everything has worked well, right? You can run this query. Now this is going to um, drop the well pollution copy, right? And then you can now run the query to the on the well pollution table, which is the original table to, you know, make the updates. So I hope that today helped you to see what this survey data is all about. I hope that you're excited as I am to get stuck in. I hope you are excited as I am to get stuck in. Till then, keep well. Okay, so that marks the end of everything.